Lesson 5.1, Perpendicular Bisectors. Your goal for today is to be able to apply properties of perpendicular bisectors. So take a moment, please pause the video and write down your objective and your title in your table of contents. Just as a review, we're going to talk about perpendicular, the definition of perpendicular, because we're going to be using that today. So as a review, two lines that meet at a 90-degree angle are perpendicular lines. So in the image you can see that the purple line and the blue line have a little red box, which means that the lines are perpendicular. And also, if you recall from way back in the beginning of the year, we talked about slopes of perpendicular lines. Slope of the first line is 2, or 2 over 1 is a fraction. The slope of the perpendicular line has to be the negative inverse of that. So if this slope is 2 over 1, I have to flip the fraction and make it the opposite of what it was. So the slope of the perpendicular line is going to be negative 1/2. Also, as a review, I want to talk about bisectors. So this particular example is a segment bisector. Tomorrow we're going to talk more about angle bisectors, but for today, let's just focus on this one. So a bisector, bi, the prefix bi means two, and this bisect means to cut. So bisect means to cut in two, and it actually means to cut into two equal pieces. So those two line segments are congruent, where M is the midpoint of line segment AB. All right, so we have a lot of vocabulary to cover today, so make sure you get your hand all warmed up before you start writing all this stuff down. First word is altitude. Go ahead and pause the video and take down your notes. All right, so I think it's also important to point out that every triangle has 3 angles, so every triangle is going to have 3 altitudes. For example, I can draw a line perpendicular. This is just a kind of a hunch. Okay, I could draw an altitude from that one, and I could also draw an altitude from this side over here, which would give me a perpendicular line there. Okay, so I can draw 3 altitudes that are perpendicular. I didn't actually do a good job of it, but you get the idea. Okay, a median is a segment from an angle to the midpoint of the opposite side. So go ahead and pause the video and write down the definition in your notes. Okay, just like with the altitudes, I'm going to have 3 medians in every triangle because I have 3 angles and 3 opposite sides, and every opposite side has a midpoint. So for example, if I want to draw a median from angle B to its opposite side AC, I'm going to guess the midpoint would be around here somewhere, so it would look something like that. And then maybe my other midpoint might be around here someplace, so then I would have something going through like that. And it is not a coincidence that those lines are intersecting at that one spot. This spot right here is called a centroid. Okay, the spot where the medians intersect is called a centroid. Okay, so we're going to kind of combine two things that we just reviewed earlier. We're going to combine perpendicular and bisector. So a perpendicular bisector is a line or line segment that intersects another line segment at a 90-degree angle, and it also passes through the segment's midpoint. So take a moment and get the information in your notes. All right, I want to just point out one thing real quick before we move on, because we haven't actually done any constructions with the compass of perpendicular bisectors yet, but I do want you to recognize these little arc things up here, which are actually created with a compass, and that is how, those are the arcs that would be used to create the perpendicular bisector. So you're going to be seeing this image a lot. You'll see it on your AZ Merit. You'll see it on your final exam. You'll see it on the semester exam. You'll probably see it on this unit exam. So make sure that when you are identifying the image of a perpendicular bisector, that it has the little arcs at the top and at the bottom, and that also these line segments are marked congruent and you have a 90-degree angle. So you need all those three things to have a perpendicular bisector. Properties of perpendicular bisectors, you'll always be given, or perpendicular bisectors will always create, I should say, two congruent 90-degree angles and two congruent line segments. So if you look at the drawing on the left, the perpendicular bisector, so this line is the perpendicular bisector of this line segment. Notice that it does not go through the angle. That's okay. It just has to be perpendicular to that base segment, and it has to cut it in half. That's all it has to do to be a perpendicular bisector. This triangle over here on the right, though, is kind of a special case, which is what we're going to be focusing on today. I have a perpendicular bisector. I can see that because these are congruent and these are congruent, but we're also going to talk about why these then are congruent to each other. So that's going to be our focus for today. Okay, before we start talking about more or get more into perpendicular bisectors, I want to talk about equidistant. So please pause the video and get the definition in your notes. Okay, equidistant is a point, if a point is equidistant from other points, it is the same distance from them. So for example, let's start at the top here. If this is the perpendicular bisector, we're going to talk about this in a second. If a point is on there, then it's the distance from here to here is the same distance from here to here. And it doesn't matter where I move the point. If I move the point to here, this distance is still going to be the same as this distance. Okay? So equidistance means a point that is the same distance from the endpoints of a line segment. All right, here we go. Main takeaway for the lesson today. Perpendicular bisector theorem. Go ahead and pause the video. And yes, you do need all of this information in your notes. It's really important. So make sure you get the information as well as the diagram. Okay, so basically what perpendicular bisector theorem says is that if I have a point that is on the perpendicular bisector, for example, this point C is on the perpendicular bisector. I know that because this and this are congruent. My two segments are congruent, and I have a 90-degree angle. That means automatic in my brain, I have a perpendicular bisector. My theorem says that if I have a point that is on the perpendicular bisector, which is this point C right here, then the distance from C to A has to be the same as the distance from C to B. So these two segments are also congruent. Okay? So that is perpendicular bisector theorem. Then we're going to have the converse of the perpendicular bisector theorem, which basically says that if I have two congruent line segments, so that means I have these two line segments are congruent, then this point has to be on the perpendicular bisector, which means I have two 90-degree angles and two congruent line segments. So go ahead and pause and get the definition or the converse of the perpendicular bisector theorem in your notes. All right, let's put it to use. So we're going to try and figure out if we have enough information in the diagram to conclude that P is on the perpendicular bisector of AB. Well, if you look closely at the diagram, it's a little fuzzy, I know, but I can still see that this segment is congruent to this segment. That tells me, according to my converse of the perpendicular bisector theorem, that because those two lines are congruent, these are also congruent, and these are 90-degree angles. So converse, because the AP is congruent to PB, or I should say PA is congruent to BA, PM is the perpendicular bisector. All right, do I have enough information to say that point M is on the perpendicular bisector? Well, I can see that the two line segments have the same unit of measure. They're both 22, which means they are congruent to each other. Oops, I should label them differently than the other two because they're not all congruent all the way around. All right, so because those 2 points, or those 2 line segments are congruent, point M is on the perpendicular bisector. That means I have 2 90-degree angles here, and then I have these segments are also congruent as well. All right, so let's see what we got going on here. Trying to figure out the distance of MN. Well, looking at my drawing, I can see that I've got a perpendicular sign here, and I also have 2 congruent line segments. So that tells me that this line is the perpendicular bisector of the triangle, which also tells me that this line segment and this line segment have to be congruent because this point is on the perpendicular bisector. So because that is true, since the segment on the right is 2.6, this one also has to be 2.6. All right, trying to find the measure of BC. So there's actually some information missing here. I should have labeled these congruent. Okay, so I'm trying to find BC, which is the distance from there to, oops, I went a little too far, didn't I? There to the bottom, right here. Okay, well, if I look really closely, I can see that this distance is 12. And if these two are congruent, that means that the other segment has to also be 12. So the whole thing has to be 24. Segment addition postulate. We learned that in the first unit. Okay, TU. I'm looking for TU. I can see from my diagram that I have a perpendicular sign here, and I've got some congruent line segments, which means U is on the perpendicular bisector of the triangle, which means this and this are congruent. Those two sides are congruent, which means they have to be equal to each other. So you could set up your equation as 3x plus 9 equals 7x minus 17, and then solve for x. And then plug it back in and find the distance of TU. All right, so I got a couple of proofs here. These are actually on your homework assignment, so we're going to do them together. Because I feel like we're getting a little bit lost on the proofs, and I want to just make sure that we're all on the same page. I don't want to lose you. I feel like we're almost there, so I want to make sure that we're doing it together and we're doing it correctly. All right, so I'm given that C is on the perpendicular bisector of AB, so go ahead and pause and get caught up so you have the entire proof on your paper. Or actually, it's on your homework assignment, so I guess we don't need to worry about that. All right, so because C is on the perpendicular bisector of AB, okay, there's all kinds of information I'm going to be able to pull out of it. Just this one statement tells me all kinds of stuff. If it's on the perpendicular bisector, that means that AD and DB are congruent. So AD congruent to DB. And that's the definition of perpendicular bisector. All right. Another thing I can say is these two angles are both 90. So angle CDA congruent to CDB. That's also definition of perpendicular bisector. All right, and then I got one of two ways I can go here. I can either use reflexive property, which is going to be my first choice. I always like to use that when I can because it's super easy. So CD is going to be congruent to itself. That's reflexive. And now I can say my triangles are congruent. So triangle ADB is congruent to triangle BAD, I'm sorry, not ADB, ADC, my bad. Let's fix that. ADC congruent to triangle BDC by side angle side. Okay, that completes that proof. I proved what they wanted me to prove. I am done. All right, last proof. This is the last problem on your homework assignment. So I have to looks like I have to make a statement reason column on this one. So statement, reason, and I'm given AC is a perpendicular bisector. Of BD. That's given. All right, I'm trying to prove that triangle ABE, so I better outline this. Triangle ABE is congruent to triangle ADE. ADE. So I can already see I've got a reflexive property going on there. I'm pretty sure I'll be listing that somewhere along the way, but I'm not going to do it just yet. First thing I want to do is identify congruent or information that I'm going to need for proving those two triangles congruent, given that AC is a perpendicular bisector. All right, well, I know that I'm going to have these two congruent line segments, and I know I'm going to have that perpendicular situation going on there with a 90-degree angle, but unfortunately, none of these things lie inside the triangles that I'm looking at. So I'm not even going to bother writing that down. It's not going to help me. So what can help me, though, is because this is the perpendicular bisector of the big segment BD, I know that these two segments are going to be congruent because that's my definition of perpendicular bisector. So I'm going to say that AB is congruent to AD, and that's going to be definition of perpendicular bisector. All right, so I have one side. Let's go ahead and list our reflexive property. AE is congruent to itself. Okay, and that is going to be reflexive. Now I need one more thing. Well, if you go back on your notes and you look at definition of equidistant, I can see that point E right here lies on the perpendicular bisector, which is this guy right here. Okay, well, if that lies on the perpendicular bisector, then E has to be equidistant from point B and point D. So because this point lies on the perpendicular bisector, these two line segments have to be congruent. So let's see, let's write E is on perpendicular bisector. I think I need a little bit more space on there. So let me extend my page out. All right, E is on perpendicular bisector. E is lying on perpendicular, and I'm going to say that's given. That was given to me in my drawing. Okay, so you'll notice that it wasn't given to me in words at the top, but clearly point E was listed on the drawing as being on the perpendicular bisector. Okay, since E lies on the perpendicular bisector, EB has to be congruent to ED, and that is going to be definition of perpendicular bisector. All right, so it looks like I have a side situation. So my triangle ABE is going to be congruent to triangle ADE by side. All right, that's it for today's lesson, and homework assignments online. See you tomorrow.